Okay, I just want to make sure everyone got 4D down. I was writing as the video stopped. So f of x equals 12 is the same thing as y equals 12. When we only have a y, that means the graph only passes through the y-axis. And if it only passes through the y-axis, that means it is a horizontal line. And horizontal lines are called the constant function, which we learned on the last page. Didn't have my papers out. So the constant function is when we have y equals a number. That means it's horizontal. Okay, so let's go ahead and move on to the next page. So we're going to practice graphing, and I did put 2 of these on your test. So both of these would be really good ones to highlight. So this is a huge topic in 09, and it's a huge topic whenever you're graphing, period. And you'll notice that your next class is almost all graphing, Math 150. It's a lot of graphing. You graph rational functions, you graph conic sections, you graph your 9 library of functions. So there's a lot of graphing. So one of the first things you do anytime you're graphing is you find where the graph crosses the x-intercept and where the graph crosses the y-intercept. So the x-intercept is found by making y 0. So you go into your equation, wherever you see f of x or y, you make that 0, you solve what's left. The y-intercept, which we found already by putting our equation in y equals mx plus b, is always 0, comma, b. So for the y-intercept, we make x 0. So it's really easy to remember. You always make the other letter 0. So for the x-intercept, make y 0. For the y-intercept, we learned when we were doing these to write 0, 2. That means you're making x 0. So you plug those into the equation and you find the missing variable. So this is what the 2 problems look like on your test. Like I said, this would be a really good idea to highlight these. So this is 1, and then highlight number 6 too, since there's 2 of these. So I'll do the first one, then you can turn off the video and try the second one. X-intercepts are when we make y 0. So the minute I see x-intercept, I immediately write y equals 0 there to remind me what I'm doing. So this is my y, remember? So I'm going to make that 0, and then I'm going to solve the resulting equation. Okay? And every single time you're given an equation, this is how you find the x-intercept, whether it's a line or a parabola or a circle or a cubic function. If you're asked to find the x-intercept, you make the y 0. So we need our x's over on the left, so let's go ahead and add 3x here. And we get 3x equals 2. Divide by 3, divide by 3, so we get x equals 2/3. Just like we always wrote the y-intercept as a point whenever they asked us with y equals mx plus b, we have to do the same thing with the x-intercept. Because if you look up the definition of intercept, it's the point or points where a graph crosses the x or y-axis. So the final answer needs to be written as a point. So this one, see why I do this? Now right here, my point's already. It's 2/3, comma 0. And students have told me sometimes Alex just wants the x, sometimes they want the point. So if you try to put in the parentheses and it won't take them, then that means it just wants the x coordinate. So Alex kind of switches back and forth, but whenever you're doing a paper pencil test, the teacher will always want your intercepts written as points. Okay, so 2/3 0 would be about right there, 2/3 of the way to 1. To find the y-intercept, we could do it algebraically, but when you have y equals negative 3x plus 2, you can see what the y-intercept is. But let's do the algebra work just so you can see it, because you won't always be able to tell by looking when it's not going to be a line. So when I see y-intercept, I say, oh, that means make x 0. So I go in this equation and I go negative 3 times 0 plus 2. 0 plus 2 is just 2. And then I write my point, which we knew what it was already. It's 0 for x, 2 for y, because we've been doing that all along, right? Y-intercept 0, 2. So then I plot the point 0, 2. And boom, I can graph the function because we know it's a line because it's in the form y equals mx plus b, so we don't need to find a third point unless they ask us to. And if they did ask you to, you could just plug in any x you wanted, like make a little mini t-table and find the corresponding y. But on this one, they're just asking us to find the intercepts and graph. So if you wanted to check it, let's say you're on a test and you wanted to check it, like I said, you could pick another x. Let's make x negative 1. And you can pick any x you want, just not 0, not 2/3. So let's just randomly pick negative 1 because it looks like it kind of crosses in a nice place. So I take my equation, y equals negative 3x plus 2. I put negative 1 in. Y equals negative 3 times negative 1 plus 2. So 3 plus 2 is 5. So if I've drawn my line correctly, it should pass through the point negative 1. Ugh, I guess I didn't draw it so good, did I? 1, 2, 3, 4, 5. So I'm a little off a little bit, aren't I? But we can see that it's close, so I just didn't do a very good job drawing it. Okay, so that's how you can check it. Find another point on the graph and then make sure your line appears to go through it or will be close to that and you can see it is. It's harder when you have fractions to get an exact line, but I thought I did pretty good with that. But I see I went on the left side of that point instead of the right. You can see it will go through that. So that tells me, yes, I did it right. Okay, so go ahead and shut off the video and try number 6. Okay, for the x-intercept, we write make y 0, and remember this is my y. F of x and y are the same thing. So make y 0, so I'm going to write 0 equals 5 minus x. Again, just like before, I need my x on the left, and I'm crossing the equal, so I'm going to do the opposite. 0 plus anything is just that, so this will be x equals 5. So I can see 5, 0 is on the graph. So there's our first point. Find the y-intercept. Remember that means make x 0. And I'm just doing the work just because, like I said, when you stop studying lines, which we do right after this chapter, then you need to know this technique. So we'll just practice it. So go back up to your equation, y equals 5 minus x, and make x 0. So y equals 5 minus 0, y is 5. So that means my second point is 0, 5. And if we want to find a point in between, like I said before, let's try 2. X equals 2, because so far I have x equals 5 and x equals 0, so I just picked one in between. If it lines up with these, then we can go, yes, I did this right. So y equals 5 minus x, put 2 in, y equals 5 minus 2, so y is 3. So let's see, does the 0.23 line up with my points? Over 2, up 1, 2, 3. Ding, ding, ding. So if Alex did ask for a third point, you just pick any x that's not already picked and just make sure it lines up with those, and then you can connect it. See, that's what I should have done here, is I should have done the third point first and then connected them, and then I wouldn't have been off by a little bit. But graphs are definitely not an exact science, especially when you're using a fat felt tip pen. Arrows on both ends. Every line must have an arrow on both ends. And there we are. So you have 2 of those on the test. Some of them, I think one of them also asks for the slope. So it asks for the slope, it asks for the x-intercept, it asks for the y-intercept. So if it asks for the slope, would you guys all be able to tell me on this one? So if I would turn it around to be y equals mx plus b, it would be y equals 0, or excuse me, not 0, negative x, positive 5. So what's the slope? Y equals mx plus b. What's in front of x? Negative 1. So if, like the test, it asks for the slope, I'd say m equals negative 1, if it asks for it. And that means you should be able to go down 1 over 1, there's a point, down 1 over 1, there's a point, down 1 over 1, there's a point, down 1 over 1, there's a point. So you can verify the slope on the graph as well. Okay, let's take a look at page 7. That was pretty easy stuff, right? So on the paper pencil test, this was like a big 25-point problem. Each of the pieces were like, maybe it's 24 points. Each of the pieces were like 2 points each, and there were 12 different questions. So on Alex, I'll probably have to put a bunch of different questions together. So I'll still try to make it worth 25 of the points, but it may not be all in the same question like this is. I love, love, love these problems. We had this on 2 tests in 091 and on the final exam, because this is good stuff when you're studying functions. So find x. So right away, I write x equals to remind myself. So it says estimate the value of x. So I write x equals when y is 0. So remember when we did this on the last lesson, when y is 0, we're right here. Draw over to the graph. What's x? X is 1. And remember how I showed you to check it? You can go over here to the side, make that an order pair, and verify. The order pair would be 1, 0. Verify that that point is on the graph. So is the point 1, 0 on the graph? Ding, ding, ding. Yes, it is. Okay, so you try the next one, because there's 2 of each one, so I want to make sure you guys get a shot at it. So go ahead and try the next one. So y equals 2. So find the value of x. So I'm going to write x equals, get it ready. So go on the y-axis, find 2, and then trace over to the graph. So what's the x that goes with that? Negative 1. And then, especially if you're on a test, turn it into a point over here, putting it in the correct order. X is negative 1, y is 2, and make sure the point negative 1, 2 is on the graph. And it is. Woohoo! Okay, now they're switching gears. Now what are they giving us? What is it that's always in parentheses? The x. So when x is 0, it wants to know what is y. So whatever's in parentheses, and you can look up here, x is always what's in parentheses. So when x is 0, what's y? Y is 1. And don't write y as 1, because this is your y. F of 0 means y equals what when x is 0. So just write 1. Change it to a point and verify it. When x is 0,